Let us briefly explain the development of lungs. If this is the head of the embryo with the stomodium, with the first, second, third, fourth pharyngeal arch, then this will be the endodermal pharynx with the pharyngeal pouches, and ventrally there is a diverticulum just behind the pharynx, and it's the lung butt or tracheal diverticulum. Both terms work. So we know that the lungs and the whole tracheobronchial tree develops from the endoderm because it shares the same origin with the pharynx. Here. So this is the lung butt, also known as the tracheal diverticulum. This separates from the esophagus. So if this will be the esophagus, here ventrally, that's where the lung bud grows. So there is a constriction here, and there is a constriction and some apoptosis here. He is ventrally, dorsally. This is the esophagus. And this will be the lung butt. From the anterior view or ventral view, we would see the lung butt growing downwards and branching into two pulmonary butts for the right and left lung. And behind there will be the esophagus. So we got two, namely the right and left pulmonary butts, and they further proliferate. So this will be the esophagus. By the way, a wrong pattern of separation of the lung butt from the esophagus can also result in a variety of developmental disorders, such as the tracheoesophageal fistula, etc. However, normally the pulmonary butts are branching further until they reach the following pattern. On the right side, we got a principal bronchus, then we got three lobar bronchi for the right lung, and the first, second, third lung segment, the fourth, the fifth, and the sixth, seventh, eighth, ninth, and the 10th segment. On the left side, we got two lobar bronchi, the upper one with 1, 2, 3, 4, 5 lung segments, and the lower with the 6th, 7th, 8th, 9th, and the 10th segment. The mesenchyma, or the pulmonary buds and the bronchi proliferate into the mesenchyma, which will constitute the connective tissues and the smooth muscle layer of the tracheobronchial tree and the lungs. So all the pieces of cartilage, all the connective tissue of the lamina propria, and also the smooth muscle layers of the bronchi and the bronchioles, all this is derived from the mesenchyma, for which I'm now adding the green layer. And moreover, the lung buds are growing into the upper part of the coelom, which becomes separated from the abdominal cavity as the diaphragm and the pleuropericardiac sacs are evolving. So it becomes separated from the pleural, the pleural cavity becomes separated from the pericardiac and peritoneal cavity, and we got two layers of the serous membrane, namely the visceral pleura that I'm adding right now, and the parietal pleura on the right side, and the same will be on the left side. Of course, this anatomical space between these two layers is more or less virtual. The scheme is exaggerating here, but let's label this. Here are the lung segments. One, two, three. Again, here is the right side, okay, and here's the left side, all the same. This will be the segments 4 to 5, segments 6 to 10 on the right side, and on the left side, segments 1 to 5 and 6 to 10. So the epithelium is endodermal. Everywhere in this tree. Then this is the mesenchyma. Of the tracheobronchial tree and lungs. So all the pieces of connective tissue and the smooth muscle develops from that layer. And then here we have the serosa with its two layers, with the visceral pleura adhering on the surface of the lung, and the parietal pleura, and the pleural cavity in between. Again, in reality, this is more or less capillary space. Let's explain the maturation of the periphery of the lungs. The first stage, it's the fetal canalicular period, or the first stage I will mention here, ranging between weeks 16 to 26. And it means that we got the terminal bronchioles that are branching into respiratory bronchioles. And that's it. We have no further branching of the periphery. And the terminal bronchioles as well as the respiratory bronchioles are lined with just simple cuboidal epithelium. The pulmonary capillaries are somehow far from the wall of the bronchioles, being separated by the mesenchyma here. So we got terminal bronchioles, which branches into several respiratory bronchioles, but these are lined with simple cuboidal epithelium. Here, these are capillaries and mesenchyma. So if the baby would be born like in this week, the breathing would be extremely difficult due to the thickness of the epithelium and the distance and the thickness of this blood-air barrier. The lungs are not mature enough. Let's compare it with the stage of the terminal sac period, which is fully developed in a newborn, where the lungs are already mature. Starting with the terminal bronchiole, we know that terminal bronchioles are branching into several respiratory bronchioles, and each respiratory bronchioles again is branching into several alveolar ducts, and each alveolar duct leads to alveolar sac, the wall of which is already made of alveoli. More importantly, these alveoli are lined with simple squamous epithelium, and the capillaries are immediately in close touch with the wall of the alveoli. So any transport of gases is much more efficient here. So this will be the terminal bronchiole, branching into several respiratory bronchioles, but this time we got more divisions here. We got alveolar ducts, leading to alveolar sac, and each alveolar sac has the individual alveoli with simple squamous epithelium. Well, also some cuboidal cells. I will make a special scheme for that. So this already is a mature structure of lungs, where the pneumocytes are lying on the basal lamina. We got the type 1 pneumocytes that are extremely flat cells. We got type 2 pneumocytes that are kind of cuboidal cells. So I will add the nuclei flat here, or more rounded here. The granules into the type 2 pneumocytes. The granules that are releasing a substance called surfactant that covers the surface of the alveolar epithelium, reducing the amount of mechanical work necessary for every expansion of that surface during every inspiration, during every breath. And we got the closely adjacent endothelium of the lung capillaries, which are of the continuous type with the occluding junctions here, and their basal lamina is fusing here with the basal lamina of the pneumocytes. So this will be the alveolus. This would be the capillary with its endothelium. The alveolus is lined with type 1 pneumocytes. The so-called membranous pneumocytes that are extremely flat, and type 2 pneumocytes that occur mostly here on the top of the interalveolar septa, but more importantly, they have granules that are releasing a surfactant substance that is spreading as a film on the inner aspect of the alveolus, reducing the surface tension of it. And this is the mature blood-air barrier. I should also include the basal lamina. Here, the basal lamina of the alveolus and the basal lamina of the capillary. So this allows for much more efficient transport of the gases than the situation in the immature lung. One can measure the maturity of the surfactant because it's also changing its chemical composition. That's what the so-called LS ratio is used for. It's it can be measured from the amniotic fluid, which is in contact with the fetal lungs, and the L stands for lecithin, S for sphingomyelin, and having this ratio above 2.4 is a sign of sufficient maturity of the lung tissue. Having this ratio below 1.5 means a high risk of respiratory distress should the fetus be born at that time point. So the development and the maturation of lungs is really important, as is one of the crucial organs that can decide about the maturity and adaptation of the newborn baby, infant.